Good evening, students. Today we are going to solve some numerical problems in the chapter current electricity. Okay. The first problem which we are going to solve today, I will read out. A radio set of 60 watt runs for 50 hours. How much electrical energy is consumed? So in any problem, I have taught you in the previous sessions also, whatever the given information should be listed first. So I have written the given quantities. The radio set is having a power P equal to 60 watt and it is running for 50 hours. So the time is given as 50 hours and the electrical energy E is questioned. Now what is the expression for the power? Okay, power P is equal to E divided by D. Therefore, E is equal to power P multiplied by time. Is it not? So this is a P into T. So this is equal to power of the radio set is how much? 60. Okay, it is 60 watt into time is 50 hours. So 50 H for hours. So multiply this 60 into 50. 6 5s are 30. So this must be equal to first 6 5s are 30. Followed by 2 more zeros and the unit is what? Watt hours. So what is the energy consumed is 3000 watt hours. How will you express this in kilowatt hours? We have to divide this by 1000. So this can be written as what? 3000 divided by 1000 will become 3. So this is 3 kilowatt hour. Have you all understood? So what is the electrical energy consumed? Is E equal to 3 kilowatt hours, that is equal to 3 units. But if you want to convert this in joule, you must remember the conversion factor 1 kilowatt hour. You see that 1 kilowatt hour is equal to how many joule? It is 3.6 into 10 to the power of 6 joule. Is it not? So 1 kilowatt hour is equal to 3.6 into 10 power 6 joule. I am going to convert this joule, that is a kilowatt hour, into joule. Therefore, now 3 kilowatt hour is equal to 3 multiplied by 3.6 into 10 to the power of 6. Now I have converted that kilowatt hour into joule. So if you multiply 3.6 into 3, roughly I am telling you how to find out roughly, okay. 3 into 3 is 9. Then 6.6 into 3 is what? 1.8. So 9 plus 1.8 is how much it is? 10.8. Okay. So this is now equal to 10.8 into 10 power 6 joule. This is the answer. Have you all understood? Okay. Shall we go to the next problem? Okay, I will read the second problem. This is very important. Okay, an electric heater draws a current of 10 ampere from a 220 volt supply. What is the cost of using the heater for 5 hours every day? Every day 5 hours, and it is used for totally 30 days. And the cost of 1 unit, that is 1 kilowatt hour, is rupees 5.20, 5 rupee 20 paise. So we are using several electrical appliances in our home, and for each appliance how much hours we are utilizing them, and how much power it is consuming, then how much total power consumed for 1 month into the duration will give you the electrical energy consumed per month. This is how the electricity department will produce a bill. So it is one such a problem. What are all the given quantities? Let us find out. So it draws a current of 10 ampere. So I will write here given. Okay, given current is equal to 10 ampere and the voltage V is equal to 220 volt. And therefore the power, what is the power? How will you find if voltage and current are given? Power is the product of voltage and current. So what is the product of this voltage and current? This is 220 multiplied by 10. and this is equal to, it's very simple. For this, we need not use any calculator. Directly, it is multiple of 10 only. So this is 2200. Okay, 2200. It is a watt. Okay. Then how many hours it is used daily? Daily 5 hours. So 5 hours every day is given. So time taken T is equal to 5 hours per day. Per day. In a day only 5 hours. Therefore, energy consumed, that is energy consumed per day is E is equal to power into time, and that is equal to what? 2200 watt into 5 hours. Understand? So this is only the energy consumed for one day I am calculating. So stage by stage, step by step you have to do. Understand? Systematically if you do means you will not go wrong. So I will multiply this. See here, 5 into 22. 22 into 5 is how much? 110. Is it not? So first I will write 22 into 5 is what? 110. Followed by 2 more zeros, and the unit is what? It is a watt hour. Watt into hour. So we have to convert it into kilowatt hour, means we have to divide it by 1000. Is it not? Okay. So 11,000 watt hour divided by 1000 is how much? 11 kilowatt hour. Am I right? Okay. So this is now equal to 1. That is 11,000 divided by 1000 is 11 kilowatt hour. Understand? So what is this E equal to? Energy consumed per day. Like that, for how many days we have to calculate? For 30 days. One day the power consumed is 11 unit. Therefore for 30 days it is 30 into 11 units. Simple. Okay. Therefore energy consumed. So energy consumed in 30 days. Okay. In 30 days is E. We can call it as E is equal to this 11 kilowatt hour, or 30 days multiplied by 11 kilowatt hour. If you multiply 11 into 3, it is 33. So this is equal to 33 followed by what? 0. Okay. So 330 kilowatt hour. This is equal to 330 units. Okay. So 1 unit of electrical energy is 1 kilowatt hour. Therefore, we can write 330 kilowatt hour as what? 330 units of energy. What is the cost for 1 unit? 1 unit, that is 1 kilowatt hour costs how much rupees? 5.20. So I can write cost of energy. Okay, cost of energy per kilowatt hour. That is per unit. Okay, this is equal to rupees. Rupees how much? 520. Therefore, we have to find the cost of how many such units? Yes, 330 units. Okay, therefore, cost of that is 330 units. Okay, 330 units. Okay, is equal to 330 multiplied by 5.20. So this is equal to what? 33 multiplied by 52, and that is found to be how much? If you calculate, I think it will come as rupees 1716. Am I right? Is it 1716? You multiply and tell me. Yes, sir. But how to do? 33 into 50 you find out first. Then 33 into 2 is 66. Is it 1716? Okay. So this is rupees. Okay. This is rupees 1716. This is the answer. Final answer. How easily we have solved the problem step by step. So in such problems, first you have to find out, okay, what are all the quantities given in the problem. List them out and try to relate them in a formula. Then in such problems, normally energy, okay, consumed per day you have to find out. Then energy consumed per month you have to find out. Then cost for 1 unit will be given, and the cost for the actual consumed unit you have to substitute and find the answer. Okay, have you all understood? Shall we go to the next sequence of problems? Okay. Now the third problem I will read. Calculate the energy transferred by a 5 ampere current flowing through a resistor of 2 ohm for 30 minutes. So after reading the problem, what I told you, list out the given quantities. So what are all the given quantities we will find out. So 5 ampere current means what? The current I is equal to 5 ampere. Then it is flowing through a resistor R. R is equal to how much? 2 ohm. And the time is given in minutes. So I will write both in minutes as well as hour. Okay. So this is equal to 1 by 2 hour. Half an hour. Okay. Because we are using the unit for electrical energy, kilowatt hour. That is why I have converted the minutes into hours. 30 minutes is equal to what? Half an hour. Okay. Now, what is asked here? Energy transferred. So first of all, power, electric power P. Power P is equal to I in, that is the I square into R. Okay, I square into R. And this is equal to what? 5 square. So this is 5 into 5 into 2. So this is equal to 50. This is equal to what? 50. What is the unit? Power is expressed in what unit? Watt. Watt. Okay, so this is what? Watt. Therefore, energy consumed. Okay, energy E is equal to power into time. So this is equal to 50 watt. Multiplied by how many hour? 1 by 2 hour, is it not? So this is 1 by 2 hour. So 50 by 2 is 25. So this is equal to 25. What is the unit? Watt hour. 25 watt hour, if you want to convert it into kilowatt hour, means we have to divide it by 1000. So this is equal to 25 divided by 1000. And this is equal to what? 0.025. So this is equal to 0.025 kilowatt hour. Understood? So first we have to list out what are all the given quantities. Then write the formula or expression relating the given quantities. Then substitute and you get the unit in kilowatt hours. So we find that the electrical energy consumed is what? 0.025 kilowatt hours. Okay, now let us read the problem number 4. An electric bulb is rated as 100 watt 220 volt. Now whenever you purchase a new bulb, on the cover it will be mentioned like this. Its power and how much voltage it can withstand. Sometimes how much current it can withstand, and what is the frequency of AC also. In some electrical appliances it will be printed. So in the bulb, on the over the bulb surface of the bulb also it will be printed like this, 10 watt 220 volt. How many of these bulbs can be connected in parallel across the wires of 220 volt line if the maximum current that can be drawn is 5 ampere. So in our home there will be 3-pin plugs. In the kitchen there will be a 3-pin plug with a big hole top. That is maximum current of 15 ampere. That is called as 15 ampere plug top. But for chargers, that is cell phone chargers and for electric fans and all, the same 3-pin plug with the small holes will be there. That is the maximum current rating is 5 ampere. So here it is mentioned that 5 ampere can be drawn. The maximum current that can be drawn from the 220 volt line is how much? 5 ampere. Okay. Now first we will see that for one bulb, okay, what are all the given quantities we will write. The power is given as how much? 10 watt, okay, it is 10 watt. And the voltage V is given as 220 volt. So what is the current flowing through the bulb? Okay, current flowing through the bulb. Current flowing through the bulb, through one bulb, okay, one bulb is equal to I. Current flowing through the bulb is equal to I. Now power P is equal to what? Power P is equal to voltage into current. Therefore, what is I is equal to P divided by V. Is it not? Power is a product of voltage and current. And how much current is flowing through one bulb? That is I is equal to P divided by V. And now this is equal to P. What is the P here? 10. So this is 10 divided by voltage is 220. So 0 is getting cancelled, and therefore this is 1 by 22 ampere. 1 by 22 is very small number, less than 1. So very feeble current only the bulb is consuming. So you see that in a parallel circuit, if bulbs are connected in parallel, means the 5 ampere current supplied by the 220 volt line is distributing itself into several branches. Is it not? So in each branch how much current is permitted is 1 by 22 ampere. Okay. So what is the number of bulbs? So what is the total current is 5 ampere. Therefore I will write total current. Okay. Total current that can be consumed. Okay. Total current that is consumed must be equal to how much ampere they have given. This is equal to what? 5 ampere. But how much current every bulb will consume is 1 by 22 ampere. So in this 5 ampere, how many 1 by 22 ampere are present? That will give you the number of bulbs. Very simple. Is it not? Therefore, number of bulbs is equal to 5 ampere divided by 1 by 22 ampere. So ampere get cancelled, and this is equal to what? 5 into 22, and this is what? 5 into 20 is 100, 5 into 2 is 10, 100 plus 10 is 110. So this is equal to 110. Therefore N is equal to 110 bulbs. Okay. Did you all understand? That's good. So as usual, write the given quantities for every individual bulb. How much power is given, how much voltage it can be withstanding is given. From that, the current flowing through one bulb you find out, and you divide that divide the total current by the current consumed by a single bulb, so that you will get the total number of bulbs that can be connected in parallel. Did you all understand? Very good. Shall we go to the next sequence of sums? That's good. Yes, read the problem number 5 now. Find the equivalent resistance, the current and the potential difference across each resistor in the given circuit. So a circuit is given to us. The circuit contains 3 resistors which are connected in series. What are their values? R1 equal to 2 ohm and R2 equal to 3 ohm and R3 is equal to 5 ohm. They are connected in series. And in series combination, you must remember that the current flowing through each resistor will be the same. Is it not? But the potential difference across each resistor will not be same. It will be different. So the net potential difference is 10 volt. It is applied across the combination. But I will take the potential difference across the first resistor is V1, across the second resistor is V2, and across the third resistor is V3. Okay. Now, first equivalent resistance. So, R equivalent is equal to R series, that is equal to R1 plus R2 plus R3. So, we have studied that the effective resistance in series is equal to the sum of the individual resistances. So, this must be equal to what? In place of R1, this is 2 ohm plus R2 is 3 ohm plus R3 is 5 ohm, and this is now equal to 2 plus 3 is 5, 5 plus 5 is 10 ohm. Okay. Did you all understand? So the equivalent resistance is the sum of the individual resistances, and we find that its value is equal to how much? 10 ohm. Okay. Now what should be the current in the circuit? Therefore current. Okay. Therefore current in the circuit. Current through each resistor also the same current only is flowing. So current is equal to I, and I is equal to V by R from Ohm's law. And this is V equal to 10 volt divided by R. This is R effective. Okay. Effective resistance. So what is the R series is equal to 10 ohm. So this is a 10 by 10 and this is equal to what? 1 ampere. So what is the effective current? We can also call it as what? Effective current or the current flowing through each resistor. Both are one and the same in series. So I effective is equal to what? V divided by R effective. This is V. V is equal to 10 volt. Okay. And resistance, effective resistance is 10 ohm. And therefore the current is equal to what? 1 ampere current. So this is equal to I. I is equal to how much? 1 ampere. So what current is flowing through each resistor also is 1 ampere. Therefore, now V1 must be equal to current I into R1 and that is equal to current is what? 1 into R1 is 2. So this is equal to 2 volt. What is V2 is equal to I into R2. So current I multiplied by R2 and that is equal to 1 into R2 is how much? 3. So 1 into 3 is how much? 3 volt. Similarly, what should be the potential drop or potential difference across the third resistance? V3. That is equal to what? I multiplied by R3. That is equal to 1 into R3 is 5. So this is equal to 1 into 5 is equal to 5 volt. Okay, good. After arriving the values of V1, V2 and V3, we have to cross check. In the series combination, V1 plus V2 plus V3 must be equal to the applied voltage V. What is the applied voltage here? It is 10 volt. If I add V1 plus V2 plus V3, it must be equal to 10 volt, is it not? Okay, find out what is V1. It is 2 volt. 2 volt plus 3 volt plus 5 volt. What is it equal to? 10 volt. Okay, this is how to verify. So for every problem, by another method you have to verify and cross check. Okay, good. Now you look at the problem number 6. Determine the equivalent resistance, total current and the current through each resistor in the given circuit. These are some competitive exam problems. You have to practice such problems. More number of problems if you practice means you will be thorough and the answers will be in fingertips so that you will be doing any competitive exam successfully. In NTSC and all, this type of problems only are being asked. Okay students, now let us find out the equivalent resistance. The circuit consists of 3 resistors which are connected in parallel. In parallel combination, suppose if the current supplied by the battery is I ampere. At this junction, the current will divide into how many branches? How many branches are there here? 3 branches. So depending upon the value of resistance, the current will divide into 3 branches. Okay. So let us take, for example, this is R1 is 2 ohm, means the current in this branch is I1, and R2 is equal to 2 ohm, and here the current flowing through this branch is I2. Similarly, if R3 is equal to 4 ohm, means the current flowing through the third branch is I3. Okay. If you add the currents I1, I2 and I3, that will be equal to the effective current or the net current supplied by the battery. Shall we find the equivalent resistance? If 3 resistors are connected in parallel, means what is the formula we have to use? 1 by R parallel. So here 1 by R parallel is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay, this is R, this is 1 by R effective also we can write. 1 by R parallel is also called as what? 1 by effective resistance, and this is equal to 1 divided by R1 is 2 ohm plus R2 is also 2 ohm. So this will become 1 by 2 plus 1 by 2 plus what? 1 by 4. Okay, so this is LCM is 4. LCM is 4. So this is 4. So this is 2 2s are 4 plus 2 2s are 4 plus 1 4s are 4, and this is equal to what? 5 by 4. This is only what? Reciprocal of the effective resistance. So 1 by R effective is equal to 5 by 4. Therefore, what is the effective resistance equal to? Therefore, what is R effective is equal to? This is what? 4 by 5, and the unit is ohm. So the effective resistance, the first one we have found the value of the equivalent resistance or the effective resistance, that is found to be what? 4 by 5 ohm. Up to this, have you all understood? Okay, so what formula we have substituted? 1 by R parallel or 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. First to write the formula, then substitute the given values of R1, R2 and R3, and taking the LCM, it is found that R effective is equal to 4 by 5 ohm. Okay, so V effective, this is equal to how much is given? Effective voltage is how much? 12 volt. It is given in the circuit itself. So R effective is 4 by 5 ohm and V effective is equal to 12 volt. Therefore, what is I effective? Therefore, I effective current. I from Ohm's law, what is I is equal to V effective divided by R effective. Is it not? From Ohm's law, I is equal to V by R. So, this is now equal to V effective is 12 volt divided by R effective is what? 4 by 5. So, this is now equal to 12 into 5 divided by 4. This is equal to 12 5s are how much? 60. 60 divided by 4 is how much? It is 15. So, this is equal to 15 ampere. Have you all understood? Good. I effective is equal to how much? 15 ampere. So here in this circuit 15 ampere. So 15 ampere of current is sent by the battery. As per the given information, the battery sends 15 ampere of current. Into how many branches this current is dividing now? Into 3 branches. So in the first branch, what is the current I? Is it not? Shall we find? So I1 must be equal to this potential difference or the voltage in parallel combination will be the same. Just like current in the series combination is constant, potential difference in the parallel combination will be constant. That is, the potential difference across each resistor will also be equal to 12 volt only. Only the currents are different. Therefore, I1 is equal to V divided by R1 and this is equal to 12. V is equal to what? 12 volt divided by what is R1? This is equal to 2. So, 12 by 2 is equal to what? 6 ampere. Okay, like that you tell me now what is I2 equal to? I2 is equal to what? V divided by R2 and this is equal to 12 divided by what is the value of R2? Good, that is also equal to 2. Okay, so 12 by 2 is equal to how much? 6 ampere. Okay, now what is the I3? So I3 is now equal to V divided by R3 and this is equal to 12 volt divided by what is the value of R3 equal to 4 ohm. 4 we have to substitute in the denominator. So 12 by 4 is equal to what? 3 ampere. 3 ampere. Therefore I effective is equal to what? I1 plus I2 plus I3. This is what? Verification. I am doing the verification. Already I have found the answer. Is it not? So this is equal to what? I1 is 6 plus I2 is also 6 plus I3 is how much? 3 and this is equal to how much? 12 plus 3 is 15 ampere. Are we getting 15 ampere? Already we got 15 ampere by another method. By this method now once again I am doing the verification. In competitive exams definitely you will have to cross check the answer quickly by another method also. Have you understood? That's good. Shall we go to the next sequence of problems? Yes. Now we are going to solve a competitive exam problem which was asked in many exams like NTSC, even JEE. Let us read the problem. Find the equivalent resistance across A and B in the given circuit. Now this type of circuit is not a simple circuit, it is a network. A network of several resistors are given and we are supposed to find the effective resistance between the points A and B. So the values given, you can read out that the outer edges are 3 ohms, all are 3 ohm and the interior resistors are all each 6 ohm. Okay. So how to do such numerical problems? The ideology I will tell you. First you start from the point A. From the point A. You see here in the clockwise direction I am going to come. So from A up to this point G, the resistance is 3 ohm. And from G and F, the resistor is 3 ohm. So this 3 ohm and this 3 ohm between G and F are in series combination. Is it not? So this 3 ohm plus 3 ohm is equal to how much? 6 ohm. So I can replace these two resistors by a single resistance of how much? 6 ohm, and that is between the points A and F. But already between A and F, one more resistor is there, that is also 6 ohm. So what is the effective resistance now? What is the effective resistance? Therefore, the effective resistance between A and F, and that is equal to what? 6 and 6 are in parallel. 6 and 6 ohm are in parallel, is it not? So this is 6 into 6 divided by 6 plus 6. So 6 into 6 is what? 36. 36 divided by 12, and this is equal to what? 3 ohm. Have you all understood up to this step first of all? So first step, are you understanding? These 3 ohm resistors are, okay, these two are in series. So the effective resistance will be 6 ohm, and this 6 ohm is in parallel with what? 6 ohm. Is it not? So what is the effective resistance between A and F? 6 ohm parallel 6 ohm. So R between A and F, the resistance is equal to what? 6 into 6 by 6 plus 6 is equal to 36 by 12 is equal to 3 ohm. So I am going to erase this now. I am going to erase this. So between this now the resistance between what? A and F. Between A and F, the effective resistance is equal to what? 3 ohm. Circuit is now reduced. Now you come from A up to F, the resistance is what? 3 ohm, and from F to E, it is also 3 ohm. Is it not? So you take that again, this 3 ohm plus 3 ohm is equal to how much? 6 ohm again. 3 ohm plus 3 ohm is 6 ohm. So what is another 6 ohm is already connected between A and E. So from between A and E, if you come through AF and FE, 3 plus 3 is 6 ohm. If you directly come from A to E, there is another 6 ohm. So it is a combination of two resistors of 6 ohm each. Is it not? Therefore, the resistance between the points A and E, so between A and E is once again equal to what? 6 into 6 divided by 6 plus 6, and that is equal to what? 36 by 12. That is also equal to what? 3 ohm. So instead of 3 ohm, 3 ohm and 6 ohm, I can replace the net resistance between A and E is found to be equal to 3 ohm. So I am going to erase this also. Okay. So these two can be eliminated, and you can see that what is the effective resistance now? The effective resistance between A and E is found to be 3 ohm only. Understand? Have you understood the second step? Now third and fourth are sequential steps only. You can guess the values. Again you see that you go between A and D. How many resistors are there? 1, 2 and 3 resistors. So between A and D, if you go through AE and ED, 3 ohm and 3 ohm are in series. So what is the effective resistance? 3 plus 3 is equal to 6 ohm. And that 6 ohm is in parallel with another 6 ohm. Between which two points we are considering is AD. Therefore, the resistance across AD is once again equal to what? 6 into 6 divided by 6 plus 6. That is equal to 36 divided by 12. And that is once again equal to what? 3 ohm. So what is the effective resistance between the points A and D? It is totally 3 ohm only. Okay. So I can replace these 3 resistors by a single resistance of 3 ohm. So I can erase this 6 ohm. These two resistors also can be eliminated, so that now the new value of resistance between A and D is equal to how much? 3 ohm. Once again, this 3 ohm and 3 ohm will be in series, so 6 ohm, and another 6 ohm is in parallel with this. So what is the resistance across R? That is AC, RAC. Okay, this is also equal to what? 6 into 6 divided by 6 plus 6, and that is equal to what? 36 divided by 12, that is equal to what? 3 ohm. It is a resistance between which two points? Across A and D. Okay. That is A and C. So this is AD, then DC. 3 ohm plus 3 ohm is 6 ohm, and 6 parallel 6 is what? 6 into 6 by 6 plus 6. So what is the effective resistance between A and C is now 3 ohm. So I am going to replace the 3 resistors, namely 3 ohm, and this is 6 ohm. Okay, can be replaced by what? 3 ohm. because the effective resistance across AC is now 3 ohm only. So this 3 ohm resistance is in series with this 3 ohm resistance. So what is the effective resistance is 6 ohm, is it not? So finally the circuit is getting reduced like this. That is it is 3 ohm in series with another 3 ohm. Okay, this is 3 ohm and this is 3 ohm. So this is what the midpoint. This is the midpoint, and this is another point like this. Okay, so this is what A, and this is what B, and this point is what C. So that these two resistors 3 and 3 ohm are in series. 3 and 3 ohm are in series, and below that another 3 ohm resistor is there. Okay, once again I can reduce this circuit like this. What this is a parallel combination of what 6 ohm. Okay, this is 6 ohm and 3 ohm. Okay, this is 3 ohm. So that so this is between A and B. So the final circuit is reduced like this. 6 ohm and 3 ohm are in parallel. Therefore RAB. So RAB is equal to R1 into R2. 6 into 3 divided by 6 plus 3, and this is equal to 18 divided by 9, and that is equal to 2 ohm. Have you all understood? So stage by stage, step by step, you will have to proceed and reduce the circuit to an equivalent circuit. The equivalent circuit may be as per your choice. My choice is like this, so that it will be very easy for us to come in a particular direction, like a clockwise direction. The same you can proceed in the anti-clockwise direction also, but the answer should be the same. This is a standard numerical problem, and the answer you can keep it in your memory forever. It is 2 ohms only. Like that, the combining numbers will be 3 and 6, 4 and 8, 5 and 10. Like that only it will be given always. Okay, you try with the different numbers and be thorough with such type. Now the last problem in this chapter which we are going to discuss today is based on the circuit. Okay, given here. Find the equivalent resistance between P and Q. This is somewhat difficult at this 10th standard level, but in the previous NTS exams and all, they have asked this problem also. Okay. Now, here the idea of potential must be remembered. This point and this point. This point can be called as P itself. This point is M. So there is no resistor in this path, means it is a simple wire. A conducting wire is taken. One end is touching P and the other end is touched at M. So the potential at these 2 points must be same. Is it not? Potential must be same. Okay. Similarly, the potential at point L and the potential at this point N must also be the same. That is these 3 resistors. Now, if I will rotate this resistor, it can be kept in parallel. I can join these 2 points. P and M can be joined. Similarly, L and N also can be joined. So that this is a parallel combination of 3 resistors like this. Okay. So these are the 3 resistors which are connected in parallel. Okay. Like this. Now, what is the effective resistance across the combination? So this will be a situation like this. Okay. So this is R ohm and this is R ohm. This is also R ohm. Now if n number of resistors, having the same value of resistance R, they are connected in parallel, means the effective resistance will be R by N. R by N. That is, there is a standard formula which we have derived in the earlier class. But here how many resistors are connected in parallel? 3 equal resistors of R ohm each. So actually it should be how much? R by 3 ohm. In competitive exams, at the moment you look at the values, you must guess the answer correctly. Anyhow, by formula also we can do. So I will find out what is the effective resistance. 1 by R parallel is equal to what? 1 by R plus 1 by R plus 1 by R. This is equal to what? 3 by R. Therefore, this R parallel, this is also equal to what? R effective. This is equal to, that is R by 3 ohm. R by 3 ohm. So by formula also we can verify the same. Have you all understood, students? Okay, my dear students, with this the chapter current electricity is thoroughly over, and during this lockdown period or whenever you are having the leisure time after the school reopens also, you have to go through the videos whenever you have a doubt and be thorough with the subject. Okay, we are closing this chapter today and we are going to start a new lesson, that is magnetic effect of electric current, in the next video. Until then, bye, see you.